Welcome to today's ArXiv CS Digest for April 8th, 2026. We received 719 new computer science papers today across 63 subfields. Let's dive into the top picks. Trend 1 of 5, Generative AI Workloads and Evaluation. This trend unifies research on understanding the operational demands, practical applications, and rigorous evaluation of generative AI systems. This cluster covers 148 papers. Representative work includes measurement of generative AI workload power profiles for whole facility data center infrastructure planning. Nirvana, a comprehensive dataset for reproducing how students use generative AI for essay writing. And personalized reward bench, evaluating reward models with human-aligned personalization. Trend 2 of 5, neural reconstruction and image analysis. This trend explores neural techniques for high-fidelity reconstruction and sophisticated analysis of visual and sensor data across diverse applications. This cluster covers 159 papers. Representative work includes MoRight, motion control done right, neural harmonic textures for high-quality primitive-based neural reconstruction, and TC, unlocking token capacity for deep compression autoencoders. Trend 3 of 5, AI agents and information retrieval. This trend explores AI agents' advanced capabilities in retrieving, processing, and reasoning with diverse information. This cluster covers 138 papers. Representative work includes evaluating in-context translation with synchronous context-free grammar transduction, a systematic study of retrieval pipeline design for retrieval-augmented medical question answering, and ClickGuard, a trustworthy adaptive fusion framework for clickbait detection. Trend 4 of 5, reinforcement learning and algorithm design. This trend focuses on designing, optimizing, and applying intelligent algorithms, especially reinforcement learning, for adaptive and robust problem solving. This cluster covers 151 papers. Representative work includes fast spatial memory with elastic test time training, how to sketch a learning algorithm, and Gaussian approximation for asynchronous Q-learning. Trend 5 of 5, formal verification and optimization. This trend unifies research on formally verifying system correctness and optimizing performance across diverse engineering and computational challenges. This cluster covers 123 papers. Representative work includes toward a tractability frontier for exact relevance certification, intertemporal demand allocation for inventory control in online marketplaces, and a proposed framework for advanced, linear infrastructure in engineering and science families. Up next, our first paper out of 5, AstraNav-World, World Model for Foresight Control and Consistency by Jintao Chen and Shanghong Zhang from AMAP Alibaba. Let's break down its key contributions. AstraNav-World is an end-to-end world model designed for embodied navigation. It jointly reasons about future visual states and action sequences within a single, unified probabilistic framework, providing a holistic approach to foresight control. This component uses a diffusion model to generate action-conditioned, multi-step visual predictions of future scenes. It provides the agent with crucial foresight into how the environment will evolve based on its planned actions. A vision language policy is integrated to derive action trajectories conditioned on the predicted visual futures. This ensures that the planned actions are grounded in the anticipated visual states, making decisions physically consistent and task-relevant. The model enables synchronized rollouts where predicted scenes and planned actions are updated simultaneously. This tight vision-action coupling, enforced by bidirectional training objectives, mitigates cumulative errors and ensures executable visual predictions. Up next, our second paper out of 5, Explainable AI Needs Formalization by Stefan Hauf and Danny Panknin from Technische Universität Berlin. Let's break down its key contributions. The paper identifies that popular XAI methods systematically attribute importance to irrelevant features, limiting their utility for diagnosis and scientific discovery. This highlights a fundamental flaw in the current algorithm-first paradigm. It proposes that researchers must formally define the specific problems XAI methods aim to solve. This foundational step ensures methods are designed with clear objectives, addressing the current lack of well-defined problems. The paper advocates for developing use-case-dependent notions of explanation correctness and objective performance metrics. This enables rigorous validation of XAI algorithms, moving beyond subjective interpretations to measurable effectiveness. Up next, our third paper out of 5, ClawsBench, Evaluating Capability and Safety of LLM Productivity Agents in Simulated Workspaces by Xiangyi Li and Hancheng Li from BenchFlow. Let's break down its key contributions. ClawsBench establishes a realistic evaluation environment using 5 high-fidelity mock services: Gmail, Slack, Calendar, Docs, Drive. These services feature full state management and deterministic snapshot/restore for consistent, repeatable evaluations. A comprehensive suite of 44 structured tasks is provided, encompassing single service, cross-service, and crucial safety-critical scenarios. This diverse set rigorously tests LLM agents' capabilities and potential risks in complex workflows. The benchmark introduces a decomposed agent scaffolding approach, separating domain skills, API knowledge via progressive disclosure, and a meta-prompt cross-service coordination. This allows for independent and combined analysis of their impact on agent performance. A robust state-based evaluator compares pre- and post-execution database snapshots to precisely score each trial. This enables the aggregation of key metrics like task success rate, unsafe action rate, and safe completion rate. Up next, our fourth paper out of 5, LongSpec, Long Context Lossless Speculative Decoding with Efficient Drafting and Verification by Penghui Yang and Bo and from Nanyang Technological University. Let's break down its key contributions. This innovation introduces a draft model with a constant size key value, KV, cache. It significantly reduces memory demands, addressing the excessive memory challenge from large KV caches in long-context speculative decoding. LongSpec employs novel position indices to effectively bridge the gap between short-context training and long-context inference. This mechanism prevents performance degradation when adapting models to extended inputs. This strategy combines fast prefix computation with standard tree attention, optimizing the management of long token sequences. It enhances decoding efficiency by addressing tree attention's inefficiencies in long contexts. Up next, our fifth paper out of 5, NativeTernary, a self-delimiting binary encoding with Unary run-length hierarchy markers for ternary neural network weights, structured data, and general computing infrastructure by Maharshi Sabharia from Indian Institute of Technology, Bombay. I'm Udaipur. Let's break down its key contributions. NativeTernary partitions the 2-bit pair space into 3 data symbols for ternary values, balance-1, 0, +1, or in sign duro, 1, 2, and a reserved structural delimiter. This forms the foundational binary wire format for ternary neural networks. It employs Unary run-length encoding with consecutive delimiter pairs to represent semantic hierarchy depth. A sequence of n delimiters marks a boundary of level n, efficiently encoding structural information like character, word, or sentence boundaries. The scheme offers flexible delimiter choice, with 11 as the primary for simple OR gate detection and 00 for ultra-low power CMOS systems. This design parameter allows optimization for different hardware and power constraints. 3 encoding variants are presented: a primary 11-sold delimiter scheme, a dual starter variant for distinct symbol namespaces, and support for both unsigned and balanced ternary data mappings. These provide versatility for various use cases. A highly efficient and robust 10-line stateless state machine serves as the decoder. Its minimal complexity and resilience to bitstream corruption make it suitable for embedded systems and reliable data transmission. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.